We are going over section 11, what is it? 4? 11 for homework. Alright, and we're starting with number 10. Alright, what's it say? Find the area of each regular polygon. So if it's a regular polygon, what's true about all three sides and all three angles? They're equal. You should be able to get this one.
It's 11. 11, I didn't get.
Okay, so watch what we're going to do. I guess you could do this a couple different ways. Let's just do it like this. Let's not worry about Apothem and all that kind of stuff. Let's just, wait a minute, let's just, I need you to pay attention, or we're just going to do it next lesson, okay? Because you guys were really concerned about this, but now I got a lot of yapping stuff. So I need you to pay attention. So if this is a regular polygon, I drew this right here, which is an altitude. I'm not even going to do that Apothem and perimeter thing. All right, I think I don't need to do that with this particular one. So, so this is the altitude. We don't know that, right? But it's also the height of the triangle, correct? What would the base of the triangle be?
12.
It would be 12. Now, the base of the whole entire triangle is 12, right? Right there. How's that? And this would be the height of the triangle, correct? Now, what happens? If this is a regular polygon and this is perpendicular, then what's true about this angle? It bisects. Now, if it's a regular polygon and it's a triangle, what are all three of the angles in here? 60 degrees. Split this in half, and that's 30 degrees. And so that's right, and then that's 60 right there as well, isn't it? Okay? So it's a 30, 60, 90. What's this little bit from here to here, though? It's 6, because we also know it bisects the angle, but it also bisects the opposite side. So that's 6. So this is the short side. We want to find the what? The long side, right? Because it's opposite the 60. What's the relationship between the short side and the long side? The long side is what? Right, it's the square root of 3 times the short side, right? Which is times 6, or what? 6 square root of 3. So that's what the height is. I don't really care that it's 10.4, all right? I'm not even going to write 10.4. I'm going to write 6 square root of 3. I'm not going to use the calculator to the very, very end. I'm not putting little decimals here, little decimals all over the place, and then adding up all these what do you call them? What's the word? Rounded, approximate answers, okay? I'm going to put it all in at the end, and then just get one answer and round that last answer. Everybody got that? Okay, so what do we have to do? We've got to find the area. Well, what's the area of a triangle? It's 1/2 the base times the height. So it's 1/2 the base. What's the base of this whole entire triangle? No, it's not 6. It's the base of the whole triangle is 12. Okay, times the height. We just found the height of the triangle, which is 6 square root of 3. All right, and now we just plug all that into the calculator. Just to make this a little bit quicker on the calculator, 1/2 of 12 is 6 times 6 is what? 36. So really all I got to do is what? 36 times the square root of 3. 62 point, what did they say to round it to? 10th.4, right, 62.4. Is that the answer? Oh, yes, it is the answer. It's in millimeters, correct? I didn't put that on there, but it is millimeters. It's area, so it's squared, so it's 62.4 millimeters squared. You should have been able to get that one yourself. If you didn't, I don't think you tried hard enough. tell you, to tell you the truth, right? This is 1, 2, 3, 4, 5. All right, here we go. This is a, again, these are all regular pentagons. That's what this whole lesson was about. Okay, it's about regular pentagons, which means all the angles are equal and all the sides are equal. So if this is 5, this is kind of, would they call this the radius of the regular polygon, right? So there you go. So what do we need to do? Find the area, correct? How do you find the area of a regular polygon? There's a little formula. What is it?
It's 1/2
right?
times the n s.
How about just do that? I write it like this: 1/2 the perimeter times the apothem. Okay. There's only one. Which one? What are you looking at?
There's 2. There's a 1/2 a times the number of lines or angles times.
Yeah, don't do that. I never wrote that down, did I?
No.
This is what I wrote down. So let's do this right here. All you got to do is learn one thing. Okay, then you can be able to do it. So it's 1/2 the perimeter times the apothem. What in the world is the apothem?
It's the line.
Is it this? Is it the 5?
No, it's the line that
Perpendicular.
It's perpendicular to one of the sides right here. To tell you the truth, if you want to make this just a little bit easier to look at, do you have to really just write that particular one right there? Watch. Instead of writing stuff kind of sideways, let's just do that. Is that all right? It's the same thing, isn't it? Would you agree? All right. The only reason I did that is just to make things a little bit easier. So I've got a nice horizontal surface down here. It just makes things a lot easier. So what do I have to do? I got to find, first of all, I got to find one of the lengths of the sides, which I don't know, and that's going to help me find the perimeter, correct? And then I need to find the apothem. That's that little a. And the apothem is from the center perpendicular to the side. Well, let's do this first. Let's draw two of those. Why do I care about having two of those? It's going to be the same, and I got a triangle, don't I? All right, so let's draw the apothem now. We'll make the apothem red. The apothem goes from here, perpendicular to that opposite side. It goes right here. Everybody see that? So that red right there is the apothem. So we need some stuff, don't we? Now this is not 60, 60, and 60, right? Because it's not a triangle. But you can figure this out. We were doing this right at the end of class yesterday, I believe. Do you remember that? Well, I don't know, is it? How do we know what that big angle is right there? Right, divide 360 by how many sides you have. Now, why would you do that? Now, look, you don't have to do what I'm doing right here. I'm just doing it to make it make sense a little bit. Look, what if I did this? Okay, look, how many of these triangles like this do I have? I've got 1, 2, 3, 4, 5, correct? So watch, if I go from here all the way around back to here again, how many degrees is that? It's 360. Okay, how many of these angles, right, do I have? I got 5 of them, don't I? All right, so what's 360 divided by 5? 72? Okay, so that is 72 degrees. So that means this angle right here is 72 degrees. Now that helps, but what angle am I actually going to use? I'm going to actually, remember I bisected this thing, right? Works every time. If I bisected this, this is going to be 36 degrees right there. Why do I care about that angle? Well, because I'm using this right triangle right here. Okay, I'm using some stuff that I know about right triangles. So I'm using this triangle right here. Everybody see that? I haven't labeled it or anything, but you see what I'm talking about. I'm trying to find this side, this A. Tell you what, I'm going to put the A on the other side just to get it out of the way. So I've got a 36-degree angle right here. Now, if you wanted to, you could find this angle, right? But why bother? Let's just use this one. Okay, you said cosine. Why? Because this is adjacent and this is hypotenuse. So we use the cosine of 36 degrees equals the adjacent over the hypotenuse. Yep, multiply both sides by 5, and let's solve for A, which is the apothem. And that's basically half of what we're trying to find, isn't it? All right, and let me just put it in here. So it's 5 cosine 36, 4.04. So we'll just say it's 4. Is that all right?
Don't you just do
I'll say 0.04.
You find the bottom one and then multiply it by 2.
Yeah. You could do Pythagorean theorem, but let's do the trig function. What's that? Use a trig function? So we want to... Is it 05? Oh, okay. Alright, so we'll go 05. And you're right, it is 05. I don't know how picky they're going to be, but we'll say 4.05. So that's what they have right there. Now, so we got the apothem, right? Let me scooch this up a little bit. So we have that. Now we got to find the perimeter. But before we find the whole perimeter, we find just this little bit right here, right? And then you double it to get the whole thing, and you multiply by 5. Or you can just take the little one and do what to it? Multiply it by 10, right? Make sense? So we got to find this. What do you want to call it? Let's just call it x. So now I've got opposite and hypotenuse. Let's use the sine. So let's go to the sine of 36 is equal to opposite over hypotenuse. Multiply both sides by 5, just like we did, and let's see what we get. Let's clear that. So it's 5 sine of 36. And that's 2.94. We'll go 2 decimal places. 2.94. So x is 2.94. All right? And so what do? Times it by, well, but what did we just say? I said about like a minute ago. Multiply by 10. Okay, I just explained it. Watch. Multiply by 2 to get the whole thing, then multiply by 5. 2 times 5 is 10. Look, multiply that by 10 in your head. What's the perimeter? Do that in your head without a calculator. 29.4, right. So the perimeter is 29.4. That's right. So now let's put it all together and let's find the area. So the area is equal to 1/2 the perimeter, right, times the apothem. You should probably put 0.1 since this is 1 decimal. I don't know. Whatever. It doesn't matter. I don't really care that much about if you're off 1 or 2 decimal places, okay? And then 59.5. Okay, so let's see what we get here. We go 29.4 times 4.05. Oh, goodness. Tried it again. I always do that. I miss that. So let's try it one more time. Or we can go 0.5, right? 0.5 times 29.4. Oh, I did it again. Why do I do that?
You just press delete. You don't have to press delete.
I know, but I'm mad, so I hit clear. So 0.5 times, let's try to get 29, let me get 0.4 times 4.05. Did I do it right that time? There we go. 59.5, is that what you said? 59.5. There it is. That's how you do it. That's not so bad, is it? Okay. So you need to know the apothem, you need to know the perimeter, so you make a right triangle out of it. I think the hardest part that people forget is actually how to find that angle right there. And how did you find that angle? You took 360 divided by how many you have. Oh, no, they're not going to all be 30. No. No, you can't assume that. All right, let's skip 12 because 12 is just like 11, and 12 is what we did a hexagon yesterday in class, didn't we? And they gave you that. Oh, now this time they actually give you the apothem, don't they? Yeah, let's do this one. Might as well. Let's pause it while I get the picture up here. Okay, let's do this one. We are doing number 22. Yeah.
So if that one is 10 and it goes down to a corner 10,
Mm-hmm.
does that mean every corner is 10?
Absolutely. It's if it's a regular polygon.
If you were to find, it gives you the apothem.
Right.
If you were to find that one corner,
Yeah.
and then you find the other corner, you find the
It'd be all the same. Yep.
Oh.
Yeah, because that's the radius. Because once you go from here to here is the radius of the circle. It's also the radius of the regular polygon. Remember, we call it radius for both of them, a circle and a regular polygon. So yeah, that would be the same for the circle and the polygon, and it would be the same for all those other points that it hits as well. Correct? All right, so what's shaded here? All the circle part. Oh, let's do it like this. We can make this real pretty. If I do it right. Actually, I have to ungroup it. Okay, so we'll fill that. What do you want to fill it with? Purple. I heard purple. Okay, and then we'll fill this with black. Is that all right? Or should I make it white? Or like that? Okay. All right, so there's the shaded. So we want to find the area of the shaded portion. Okay, so basically, in general, what are we going to do? We're going to find the area of the circle, the area of the pentagon, and then do what? Subtract them, okay? So the area of the circle is easy because you already know the radius of it, right? So what's the area of the circle? I'll put C for circle. It's pi r squared. Okay, so it's what, 100 pi, right? All right, so we'll just leave it that, 100 pi. So let's keep that for right now. We'll come back to it. So the hardest part of this is just finding the area of the pentagon, which we just finished doing, isn't it? All right, so let's do it again. Let's do it a little faster this time. And then we'll draw the apothem. Okay, we've used this number already. It's a pentagon, so 360 divided by 5, would we say that was? 72, right? Half of 72 is 36, so that's 36. It's really the same thing. Do I even need to go through this again? I do? We just did one. We just did one. Come on. I think you can deal with that. Okay, look back at the other one. You can deal with it. Find, what are we trying to find? Find the apothem and find the perimeter so we can find the area of this pentagon, right? So then you would go, the area of the pentagon is 1/2 the perimeter times the apothem, right? You can do all that. Call that x. We just finished doing that. We just finished doing that. I don't think I need to do that twice. So let's do another one. Let's do 24 then. Let's look at 24. All right, that was easy. I got a nice little triangle inside of a circle. And only took me a second to do it. Watch the video. It proves it. It only took me... All right, so... no, I did not record it. That's why everybody's laughing. All right, so...
Inside joke with us triangle.
Yeah. Yeah, we're so cool. We're such cool people. All right, so really, watch. What do we have to do? We have to find the... first of all, I got to find the radius of the circle, and that's not given to us, is it? So we're going to have to figure out what that is. Let's make that... All right, so we're going to have to figure out what the radius of the circle is. How are we going to do that?
I don't know. We didn't even know how to do a triangle.
I don't know either.
Figure out the area of it.
We'll have to think about it. Let's just do what we can do. We can figure out the area of this triangle, though, can't we? Because it's a regular triangle. So the whole thing is 2. So what's this? That's 1, correct? It is, and this is 60 degrees. How do you know that's 60 degrees? Because it's a equilateral, or it's a regular triangle. So, and then that's 90 degrees, and then that's 30. The whole thing is 2. The whole thing is 2. So this is half of it because it bisects it, right? So this right here is 1. And so what does that mean? That means, what do we want to find? We want to find the height of this, don't we?
Yep.
So it's 30, 60, 90. This is the short side. This is 1 times the square root of 3, which is just the square root of 3. All right, so now if I want to find the area of the triangle, area is 1/2 the base times the height. The base is 2, and then, right. So what's half of 2? It's 1. So what's the area of this? It's the square root of 3. So the area of the triangle is the square root of 3. So now we have to find the area of the... No, it's not half of both of them. If you multiply, you don't distribute the half through both of these. Look, if you did 2 times 3 times 4, you don't go 2 times 3 and 2 times 4, right? You just go 2 times 3, figure out what that is, and then multiply by that. Okay. So the area is the square root of 3. So now what we have to do is we got to find the radius, don't we, of the circle.
Yeah.
So how are we going to do that?
No idea.
I tell you the truth, I really don't know. I'm gonna try some things. So if we went from, find the diameter, then we'll find the radius. So it looks like, so we could do, let's go to there. Remember the center of the triangle? Ah.
Which one was it? Where you bisect the angles, or you what's it called?
Yeah, that's a good idea. Wonder if we're gonna go that way or not. Let's do this. Let's do this. Let's I'm trying to remember. I can look it up. I forget what chapter it is. What if we do this? What if we went all the way across like that? It looks like it would hit the center, wouldn't it? And bisected that angle right there. I don't know if we're going to do that or not, but I kind of like Alex's idea. Actually. Yeah, and... Oops. Well, we haven't done it yet. I mean, we might look at it. Shh, stop with that, okay? Look, if we figure it out, then we know how to do it. Then you hope it's on a test, right? That's what you should. You should, after we figure it out and learn how to do it, then you should want it to be on a test. Okay, so watch what's going to happen. We're going to bisect this angle, and we're going to bisect this angle. So where does that put you? It puts you at the center, doesn't it? Okay, so if I bisect this angle right here, I should go right like that. So if I bisect all 3 of those angles, it should put me, I think they call that the centroid. Is that what it was called? Yeah. So that's the center right there. And that's important because I want to find this length from here to here. So in fact, let's...
Oh, is this one where it's like 2 times the size of the other?
So in center is... I forget what the name is. But look, if I bisected this angle, then what's this angle right here? It's 30 degrees, isn't it? Okay, well, if this is 30 and this is 90, then that's got to be 60. We already know this side right here. What are we trying to find? We're trying to find this blue one, right? Because we're trying to find the radius, aren't we? We're trying to find the radius of the circle. So this blue one right here is going to be the radius of the circle. So this is the hypotenuse. This is the long side. So what's the short side? We know the long side is 1. What's the short side?
1 divided by the square root of 3.
It's 1 divided by the square root of 3, right? Or square root of 3 over 3, right? That's 1 divided by the square root of 3. Now, how do you find the hypotenuse if you know the short side? You double it, 2 square root of 3 over 3. So the radius of this circle is 2 square root of 3 over 3. So how do you find the area of the circle? It's pi times this squared. Watch, let's square this easily. 2 squared is 4. Square root of 3 squared is 3. Over 3 squared is 9. So it's 12 over 9. So it's 12 pi over 9. So the area of the circle is this. So do this. Put that in your calculator. Put that in your calculator. Subtract them. And I sure hope you get 2.5. No, hang on to it. I'm going to give you, actually, we didn't do the second half of this with all that, what do you call that, composite figures. So just hang on to it, and we'll go over the second part of this tomorrow, okay? Yes, yeah, absolutely. If you keep your homework, then finish it. Absolutely. So there you go. No, I don't expect you to remember it. So you go back on YouTube and you watch it, and you do it yourself a couple times, and then you will remember it. Absolutely. If you just sit here and watch me do it one time, you're not going to remember it. Okay? Very good. So you put this minus this, which is right here. See? This is 12 pi over 9 right there. Okay, minus the square root of 3, and then it gives you 2.5, and that's the shaded area.
I'm just kind of frustrated that the book expects us to know that thought process.
Well, really, if you look at it, everything in here we've actually taught before and gone over before.
I mean, yeah,
it just took. Yeah, you're right. There's a lot of stuff to remember, but that's life in honors geometry.